Welcome everyone to Current Affairs by Civils 360 IAS Academy. In this session, we will be discussing about NavIC. So NavIC was in news recently because there was reports that we do not have the 4 required satellites to actually triangulate a position on the Earth, right? So basically our capacity to locate certain things is actually now lost. So that military, that strategic capability has been lost. So that was the news. So to triangle a particular object on the surface of the Earth, you actually need 4 satellites. Okay, so the first 3 satellites is actually for latitude, longitude and altitude, and then you need another satellite to correct for that time differences, right? So time difference in the sense there is a time difference between your device, the receiver device, as well as the satellites. So you need a 4th satellite to actually use the data from these 3 satellites as well as its own to correct for that difference with the receiver time. So you need 4 satellites to actually calculate the location of, accurately calculate the location of a particular object on the surface of the Earth. So India, they had this capability, but as of now, as of today, we do not have 4 functioning satellites. So we'll see why that is so. What is our, just like the Americans have the global positioning system, GPS, we also have our own Indian regional navigation satellite system, or what we call as IRNSS, right? And its operational name is called NavIC, which is actually short for Navigation with Indian Constellation. So it is actually a series of, there are 2 generations of satellites involved in this NavIC system. So the first generation satellites were actually called IRNSS series. Okay, and the second generation satellites are what we call as NVS series satellites. So we will see all those things. Okay. So to start off with IRNSS, it is actually the same as NavIC, they are both the same. Okay, IRNSS is actually what we can say is that it's actually the name given by the state, and the operational name is actually NavIC. Okay, so there is a chance that they can even ask this for the mains as well, right? In GS3 science and tech is there, right? Space is actually one of a favorite theme of UPSC. So please study this in that sense. So identify the keywords. What's the use of such a navigation satellite system? Right, that constellation of satellites is actually useful for PVT services, position, velocity and timing services. Okay, just understand the coverage. Okay, as of now it covers 1500 kilometers. Okay, now the plans are there to extend it to 3000 kilometers. Okay, 10 to 20 meters of position accuracy and 40 nanoseconds of time accuracy. Okay, I know these are numerical facts, but sometimes for UPSC prelims they may ask a number and they may give an absurd value, right? So you need to know the range of the values to identify if whether a particular value is absurd or not. Okay, so remember 10 to 20 meters of position and 40 nanoseconds of time accuracy, right? Remember that it covers from the 30th parallel south, which actually refers to the latitude. Okay, it refers to the latitude, and this is actually the longitude. So 30 parallel south actually refers to 30 degrees south of the equator. It lies across Australia, and 50th parallel north. Okay, between 30th meridian east as well as 130th meridian east. Okay, so that is the rectangle that within which our navigation, our satellite system, okay, NavIC could have or has the capability to identify the asset. Okay, the assets. Okay, so it has 2 levels of service. One, as of now, the frequency and the uses of NavIC is actually restricted only to the military. Okay, so basically there are certain frequencies civilians are not allowed to access those kind of frequency. Like for example, L5 band, S band frequencies, they are dedicated to military users. And as of now, we will see that there are 2 generations of satellites. The first generation satellites only use the L5 and S frequency, which are used by the military. So technically speaking, those satellites are for military uses only. And now we have recently launched a new NVS-01, okay, which is the second generation satellites as part of this constellation system. The second generation actually uses L1 band frequency as well, and the L1 has access to, or it provides access to civilian users as well. Okay, so only the NVS-01 that has been launched by the GSLV rocket launcher has a civilian use. The other series of the first generation satellites are dedicated for military, okay, restricted use. Okay. Okay, now we will see that originally there were 7 satellites. These 7 satellites were actually part of the first generation of IRNSS satellites. Okay, and 3 of these, like if you look at the orbits, okay, 3 of these orbits are in geostationary and geosynchronous. So generally these satellites are located in the geostationary and geosynchronous orbits. Okay, please keep that in mind. Okay, and I have told you that the first generation satellites uses the L5 and S band, okay, and therefore military used. Okay, so what happened was that, so the name of the satellites is actually, they are named like this, okay. There are 7 series of satellites which were launched first, which are part of the first generation. Their names actually start from IRNSS 1A, 1B, 1C, 1D, 1E, 1F, okay, 1G and 1H. Okay. Okay, so these were the satellites. One was actually a replacement satellite. Okay, so these were the series of the first generation satellites that has been launched. And why this 1A was actually failed first. Okay, and the failure was actually linked to the failure of the atomic clocks. So basically how these satellites actually work is that they have atomic clocks, and these atomic clocks, they are usually there are 2 types of atomic clocks, cesium based and rubidium, right? Rubidium is more cheaper, kind of like. Cesium is more accurate. So basically how the atomic clock works is that these particular, so I'll just explain the principle of how that actually works. So in the atomic clock, you will have a particular atom, and this atom will be hit with a microwave, okay, a radiation. Okay, and the frequency of that radiation that actually generates the maximum excitement in that cesium or rubidium, whatever it is, material will be locked. Okay, that particular frequency will be checked. That is constant throughout the universe. That is the purpose of atomic clock. Okay, so that frequency at which you will get the maximum excitement in a particular atom or in that cesium or rubidium, that frequency is checked, and that frequency cycles are actually counted. Okay, that frequency cycles will be counted, and they will set, okay, this much cycles. If it crosses that particular, there will be a check, right? So I'll just briefly explain. Don't get too too absorbed into this. So there will be the atom. Okay, the atom will be hit with a microwave radiation. Okay, and the frequency that generates the maximum excitement of that cesium or rubidium will be checked. Okay, a particular frequency. Okay, a particular frequency. Now, at that frequency, this frequency will be locked, and then it will be counted. There will be like a stopwatch. Okay, that actually records the cycles. Okay, and they will fix a certain number of cycles as 1 second. Okay, that is the SI unit. Okay, I think it's like close to 9 billion for rubidium or cesium. So cesium, like a particular frequency will be there. At that frequency, if that frequency wave 9 billion cycles, if it crosses that particular a particular stopwatch or something like that, a circuit like that, that will be when 9 billion cycles will cross, it will be 1 second. Okay, so this is how atomic clocks actually work. Okay, and if you replace the microwave radiation with an light radiation or optical wave, it is an optical clock. Okay, it is more accurate than atomic clock. Optical clocks are more accurate than atomic clocks. They will lose only 1 second in 1 billion years, so it's very accurate. They are more accurate than atomic clocks. So basically what happened to our system was that these atomic clock, they are stopped functioning. So they were actually imported from a Swiss-based company, and these atomic clocks stopped working, and IRNSS 1A actually failed because they are no longer able to calculate time. Okay, they are no longer able to calculate time. So 1A failed and it was replaced by 1I as well, 1I, right? So please just keep that in mind. So NVS, then the second generation was actually launched, NVS 01, okay, was actually launched in 2023. Okay, so as of now we only have 1B, 1F, 1I as well as NVS 01, and 1F is also failed. Okay, 1F also failed in 2026, so we are stuck with only 3 operating satellites. This was a failure. When we talk about failure, it actually means the atomic clock actually failed. Okay, so basically one of the reasons why we actually these clocks were actually failing was that it was imported some technical defects. So our Space Application Center located in Ahmedabad, they have developed their own indigenous Rubidium atomic clock that has been used in NVS. NVS actually uses our indigenous Rubidium clock developed by Space Application Center, and although that clock also, to develop that, we had to import a lot of components. So India and Israel, ISRO and Israel, they are entered into an MOU to develop a Rubidium based atomic clock. Okay, that is completely indigenously developed. Okay, that MOU has been signed. Okay, then remember NavIC, we are actually trying to develop NavIC, and NavIC is actually compulsory in mobile phone devices as well. Okay, mandatory in mobile phone devices. Okay, then please remember we are actually trying to develop under the Times Dissemination Project overseen by the Ministry of Consumer Affairs, Food and Public Distribution. NavIC, we are trying to develop NavIC into the GPS. Okay, to replace GPS. Okay, from 2025. So right, so this is basically the gist of the issue. So once again, just to recap, remember NavIC, remember they are in the geostationary orbit. There were 7 satellites. There is 2 generations of satellites. The first generation consists of IRNSS satellites. The second generation NVS satellite, of that only 1 is launched. Right, and now we have only 3 functioning satellites, and the failure was linked to atomic clocks. I briefly explained how they function, and we have developed our own indigenous Rubidium based atomic clock. Okay, and remember there are 2 uses. Okay, the L5 and S band frequencies used by the satellite are only dedicated for military. Only military can access those frequencies. Okay, civilians can access only the L1 band, which is only there in NVS 01. Okay, so please understand the NavIC, what is the purpose. Also look into other GPS system, okay, other not GPS system, other positioning system of various countries. Like for example, China has Beidou, right? Russia has GLONASS. Okay, Europe has Galilei, their positioning system. So each country has different positioning system. Okay, so please study NavIC. It's important for UPSC prelims. Also study for GS3 perspective as well. So that's all in this session. Thank you.